This is Mrs. Carnes. Today we're going to be talking about congruent figures. Now, you've seen the word congruent before. Congruent means that identical in form. And this is the symbol that we've used to show that two things are congruent. You've talked about congruent angles or congruent line segments. And so what we're going to take a look at now are congruent figures. Now, a polygon is a figure, so we're going to say congruent polygons have congruent corresponding parts. And the corresponding parts that they're referring to mean all of the matching sides and the matching angles. So these two polygons are identical in form, and so since they're congruent, we know that all of their corresponding parts are also going to be congruent. That means that we could say that segment AB and segment EF are going to be congruent. They're the same length. We can say that segment BC and segment FG are congruent. We can say segment GH and segment CD are congruent. And we can say that segment AD and segment, that needs 3 lines, and segment EH are congruent to each other. So we know that all of the pairs of matching sides are going to be congruent. We also know that all the angles are going to be congruent. Angle A will be congruent to angle E, angle B will be congruent to angle F, angle C is congruent to angle G, and finally angle D will be congruent to angle H. And so now that we know that all of the corresponding parts are congruent, we can say that those polygons are congruent. Now the way you would write this is we would start off with A, B, C, D. Polygon A, B, C, D is congruent to polygon. Now we have to go in the same order. We have to go corresponding vertice to corresponding vertice. So if we start here and went A, B, we can't start at F and go F, G, H, E. We have to go in the same order. Since we start with A corresponds to E, so we have to go E first. Then we went from A to B, so we have to go from E to F, and then we have to continue in that same order. It's very important that you write those in the right order because it's corresponding sides and corresponding angles. So there we go. Now we know that polygon ABCD is congruent to polygon EFGH. Now let's get a little bit more specific. Let's look at the specific polygon, which is a triangle. Now, two triangles are congruent if all 3 pairs of corresponding sides and all 3 pairs of corresponding angles are congruent. So when we take a look at these two triangles, we know that segment AB is congruent to segment DE. Segment BC and segment EF are congruent. Segment AC and segment DF are congruent. We also can very clearly see that each pair of corresponding angles are also congruent. Since all 3 pairs of corresponding sides and all 3 pairs of corresponding angles are congruent, then we know that these two triangles are congruent. So we would state this as triangle ABC is congruent to triangle, check your order, we went A, B, C, so we have to go triangle D, E, and F. And those two triangles are congruent by definition of congruent triangles. Now let's take a look at a proof of this. We're going to start looking at what's called a 2-column proof. So here they're asking us to prove that these two triangles are congruent. So if we wanted to prove that the two triangles were congruent, we have to come up with some statements and some reasons to be able to do so. Now this is just the beginning of 2-column proofs. The way you get really good at doing them is by practicing different problems over and over and over again. And you're going to see lots of them in the videos to come. So the very first thing that I would take a look at it is I would realize that my segment AC is congruent to segment EC. And the reason I know that those two segments are congruent is because it's given to me. it was drawn in my picture that that segment is congruent to that segment. I could just as easily say that segment BC is congruent to segment DC, and those are congruent also because the picture gave that to me. I could say that the third side, angle or side AB, is congruent to side ED. Notice I have to go in the right order with my segments, and again, that was given to me. It's also been given to me that angle A is congruent to angle E, and angle B is congruent to angle D, and that's all the pieces of given information I've gotten. I've taken care of that side, of this side, of my third side, so I have all three sides. Sometimes on my two-column proofs I like to write this as a S, an S, and an S. That just tells me in my brain that I've taken care of all three sides, so I have three pairs of congruent sides. And then I take a look, and I've gotten angles here. I know that angle A and E and the pair of B and D, so these would be my angles are congruent. Unfortunately, I can't state that these two triangles are congruent yet because I have three sides, but I also, by definition of congruent triangles, have to have three angles. And so what we're missing is this third angle here. How can we state that this angle is congruent to this angle, or is it? And we actually can. We can state that angle ACB is congruent to angle ECD. Notice how we had to go in the right order. And it's not by given because it wasn't given in my picture. This is by the vertical angle theorem. The vertical angle theorem states that if you have vertical angles, then their measures will be congruent. So now we have our third pair of angles. So we have all three pairs of sides and all three pairs of angles. So we can now state that the two triangles, triangle ABC, is congruent to triangle EDC by the definition of congruent triangles. And now we've proven that those two triangles are congruent. Now you're going to see in the next few videos that we actually don't need all 6 pieces of that information to be able to prove that two triangles are congruent. There are ways to shorten it down. There are theorems and postulates that will help us do this. So let's go ahead and move on to the next video.